backtracking is well known in PV plants located on horizontal terrain. But how does it compare to plants on sloping terrain? This case eliminates earthwork costs and allows for installation in more locations. However, it causes a loss of production because the terrain blocks part of the sky. In this project, we aim to estimate the production of bifacial single-axis tracking PV plants on terrains of any orientation and develop control algorithms for their trackers. To this end, we have developed a 2D model based on view factors and incorporated it into our photovoltaic plant simulation tool, SISIFO. This model enables us to calculate new backtracking angles, shadow positions, and all irradiance components, front and back, for bifacial plants on sloping terrain. This allows us to consider different cases. For example, we can answer the simplest case as shown in the figure. A PV plant located in Madrid with trackers on a north-south orientated axis on an east-west orientated slope using a typical meteorological year. The graph on the right shows us how we can vary the east-west slope of the terrain while keeping the trackers orientated in the north-south direction. On the y-axis, we can see the sensitivity of the various components of the annual irradiance, front and back, and the annual production of a bifacial PV plant to such a variation in slope. However, there are 3 degrees of freedom, 2 in the terrain's orientation, north-south and east-west slope, and 1 in the tracker's axis orientation on the land. In a more advanced case, we can vary 2 parameters, not just 1, to show the sensitivity of the irradiance. In this case, frontal on the inclined plane as we vary them. This is shown in the figure on the right. Here we place the tracker's axis in different orientations than north-south while we vary the east-west slope and keep the north-south slope fixed. Interestingly, misaligning the tracker axis can compensate for much of the loss caused by the plant not being on level ground. In conclusion, this model and tool allows us to stimulate bifacial plants with all 3 degrees of freedom. This means we can use terrain with any north-south and east-west orientations combined, and with tracker axis aligned in any orientation. Furthermore, we can move the calculation of the backtracking angles to the control of the real PV plant trackers. This also works in multifaceted terrains.